Hello, students. So today we understand how and why do we study ordinary differential equation, right? So differential equation have very important role in science and engineering field. Okay. So why do we study? I will start by saying that if you think of any example, any physical system where you can define that physical system in terms of two parameters. Maybe let me call it one y and one x. Okay. So usually we are in the habit of dealing with two variables. So that physical system that you chose has say two parameters, y and x. Okay. So you can study that physical system by having some understanding between these two variables, right? How do they change? How do they depend on each other? All right. Now, if I'm going to call one variable as dependent variable, okay, and another as independent. So as you can see, their name itself is self-explanatory, dependent, okay, variable. Now, we will be dealing with similar variables. So any physical system can have more than one dependent variable and it can have more than one independent variable, right? So coming to the point, ordinary differential equation, right? So you can study a system by understanding these two variables, okay? But it is better to understand that system if we understand the rate of change of variable, right? What do I mean if I write dy by dx? dy is just a small change, okay? A small change in what? Y, and dx is a small change in x. Here I'm going to take y as a dependent variable and x as an independent variable. By the way, we are used to the fact that y is dependent and x is independent, but it may vary, okay, depending on the situation. And dx is a small change in x, right? So when we study change of y with respect to x, it becomes easier for us to understand any physical system in science and engineering applications. Okay, that is why the ordinary differential equation play a very important role in our uh, understanding of the world. Okay, so for example, you can understand heat transfer, you can understand, rate of growth of bacteria, so many things. Okay. And from even our elementary schools, high school, and maybe like from high school onwards only. So you are in the habit of doing rate of change of x with respect to time. Okay. So what do you define it as? Velocity or speed, depending on x. And again, if you define a higher order derivative, you differentiate it again, then you'll have d2xy dt square. This again defines as acceleration. All right. Whenever a system changes with respect to time, we define it as a dynamical system or dynamic system. Okay. So this is what we study with the help of ordinary differential equation. So in this short video, I'm going to basically introduce ordinary differential equation. Okay. So what do you study? So once you define the relation, if you are trying to model a physical system and you found a relation between a rate of a variable, let me call it dependent variable, and some independent variable x or time, then you have yourself a differential equation. Okay. Now, moving on, what do you study? How do you begin with? So you define first thing in differential equation as order. Second is you define degree. Third is you define whether it is linear differential, linear ODE. Okay, I should also mention why ordinary differential equation and what else are there, like partial differential equations. So linear or non-linear. I will define all that, but before that, let me uh, mention the difference between ODE and PDEs. Okay. So when you have one dependent variable, okay, let's say y, it could be x, anything, and you have one independent variable, one independent variable, say x or time, y or z, okay, then or by the way, x or t. Okay, you have only one dependent variable, one independent variable. So what you do, you try to find the rate of change of one with respect to the other. For example, dy by dx. Okay, when this is the case, you can define ordinary differential equation. All right, but when you have more than one dependent variable or and sorry, more than one dependent variable and more than one independent variable. Okay, or you have one dependent variable, but you have more than one independent variable. All right. For example, y is a function of x and t, where x and t are independent variables. Then you get partial differentiation. You do partial differentiation. That means y can change with respect to x as well as y can change with respect to time, right? Then you get partial differential equation, right? Whenever your differential equation contains partial derivative of a dependent variable with respect to several independent variables. By several, I mean more than one. Okay. So then you have partial differential equation. As I already defined differential equation is nothing but a relation between derivatives and its dependent variable, maybe independent variable, both. Okay. That is differential equation. It will become ODE when you have only one dependent variable and only one independent variable, and it will have PDE when you have derivatives of a dependent variable with respect to several independent variables, right? So by derivative, I mean partial derivative, right? So y, for example, you denote del y, partial y upon partial x or partial y upon partial t. Okay, fine. Now let's come to the order, degree, linear ODE, non-linear ODE, and I will also talk about how you find ordinary differential equation. Okay, how do you create ordinary differential equation? Okay, so first is order. So how do you define order of a differential equation? Order. Order is the highest order derivative. Sorry, derivative. Order is order of, right? Highest order derivative. For example, let's say you have a differential equation d2y by dx square plus dy by dx plus 6y is equal to x. Okay. If you have this differential equation, what is the order of highest order derivative? 2, right? So order becomes 2. Okay. What is degree? Degree is the power of highest order derivative. Okay. But you have to make your differential equation free from radicals or powers, like, sorry, fractions. What do I mean by that is, see, let's say I have this, by the way, if dy by dx is given, you can write as y single prime, And if you have d2y by dx square, you can write y double prime similarly. Okay. So for example, I'm going to write in terms of this. Let's say I have this differential equation y prime is equal to 1 plus y double prime to the power 1 by 2. Okay. You have to find degree and order. Okay. So like I said, you have to make, to find degree, you have to make your differential equation free from these radicals. Okay. So you square both sides is equal to 1 plus y double prime. So what would be order? Order would be 2. And what would be degree? See, if you'd have gone here, what you'd have said, degree is half. No. So degree is 1. Power of the highest order derivative. Okay. Now, how do you say your differential equation is linear or not? So when your differential equation would be linear, then this is what you have to look for. There should not be any power of your dependent variable. Hang on. There should not be any power of your dependent variable. If your dependent variable is y, then y should have power 1. And there should not be any, and I said and there should not be any power of your derivatives. No power more than 1. Okay. So your dependent variable and your derivative should have power 1, and they should not be in product y dy by dx. So this has power 1 and this has power 1 and this is absent, that is not present, then you will say your differential equation is linear. Okay. And if this case, any of this case is violated, then your differential equation becomes non-linear. I will give you examples. Okay. For example, you have y triple prime plus y double prime plus y prime plus y is equal to x square. This equation, see, it can have product of x independent variable. This is linear. But the minute you got this term, sorry, plus y is equal to x cube, then is this a linear differential equation or non-linear? It is a, it has a term where dependent variable and its derivative are in multiplication. Okay, so this is non-linear. All right. Now, moving on to the formulation of differential equation. Formulation of differential equation. Okay, how do you formulate? Let's say I have a function x, y, and c is equal to 0. This equation, what does it tell you? Is it not a family of curve? Family of curve, right? For different value of c, you will get different family of curve, where y being dependent variable, x is independent. Okay. How about this? X, y, k, l is equal to 0. This is also a family of curve. Okay, where you will get different family of curves for different values of k and l. Okay, if you are given such equation, how will you find the differential equation? Okay, so for example, for first family of curve, you need another equation. You need, if number of constants are 1, you will need two equations. One itself, this equation itself, plus additional one equation you will need for finding out differential equation. All right. Similarly, For this equation, this one, you have how many constants? Two. You will need three equations. So one equation is itself this one. Other two equation you have to find out. How will you find? You will find those equations by differentiating these given curves. All right. So I will give you examples. Okay. For example, you have this y is equal to mx to the power 4. Find the differential equation for this given equation. How will you do? So you have one constant, but you will need another equation. One for one constant, how many equation you need? Two. So one equation is this. Second is you differentiate. dy by dx is equal to 4mx to the power 3. Now, why? Okay, hang on. I forgot to tell you. Why do you need these extra equations? Basically, you need these equations to eliminate the constants. Once you eliminate the constants, you find the relation between derivatives of dependent variable and independent variable. That is nothing but the ordinary differential equations. Okay. So you are trying to eliminate this constant. Just put value of m from equation 1. This is your second equation. Okay. Once you eliminate m is what? Y by x to the power 4 into x cube. This is what? 4y by x. And this is y prime. Okay. Now, what is your differential equation by the way? X y prime minus 4y is equal to 0. By the way, tell me one thing. You found this differential equation with the help of original equation, right? So this original equation will always satisfy your differential equation. So note that. Now, is this linear? Tell me degree. Sorry, tell me power. Order. Order of this differential equation. One. What is degree? Degree is 1. Is it linear or non-linear? See, to rewind, the derivative has power 1 and dependent variable has power 1 and they are not multiplied with each other. So it's a linear differential equation. Okay. And in the next video, I will talk about formulation of solution, how you find the solution of first degree, second degree differential ODE, ordinary differential equations. Okay. Thank you so much for watching the video. Do subscribe to the channel and let me know your feedback. Okay. Thank you.